by applying a constant horizontal force. The coefficient of kinetic friction between the crate and the floor is 0.15. How much work does he do? Again, as I told you, first of all, write down all the quantities that are given to you. You are given mass of the body, you are given distance through which it has to be moved, you are given the coefficient of friction. So, weight of the crate, WC stands for weight of the crate. Weight of the crate is simply mass 50 into G. G you can take 9.8. Work done you know is force into displacement. And what is force of friction? Mu into R, and R is equal to weight of the crate. Normal reaction किदे बराबर होंदी है? Weight of the body दे, ये horizontal surface है तो. So your formula for force of friction becomes mu into mg. So you have to find out the work done. Work done is force into displacement. Angle is 0 degrees because you are moving the crate, the worker is moving the crate on a level floor. So the angle between the force and the displacement is 0 degrees. So F, that is the force that he will be applying, is just against the force of friction because he is not accelerating the crate, he is just moving it. So force of friction is mu into weight of the crate. Weight of the crate क्यों लाए थे? क्योंकि normal reaction weight of the crate दे बराबर होंदी है. Weight of the crate is equal to mass into acceleration due to gravity. So force of friction is mu into mg. Put the values here, you get mu mg into s. So mu पता है सानू 0.15 है, m पता है 50 kg है, g you know is 9.8, distance through which it has to be moved is 7.5 meters. So these are the values that have been put up. To find out the work done by the worker, it is 0.15 into 50 into 9.8 into 7.5. If you make these calculations, your answer will come out to be 551.25 joules. Then a body of mass 2 kg initially at rest moves under the action of an applied horizontal force of 7 Newton on a table with coefficient of kinetic friction 0.1. You have to calculate the following. What is the work done by the force? What is the work done by the friction? What is work done by net force? नेट फोर्स की होएगा जो फोर्स अप्लाई करोगे उस जो फोर्स ऑफ फ्रिक्शन माइनस कर देना है. चेंज इन किनेटिक एनर्जी ऑफ द बॉडी. लेट अस सी what you have been provided in the numerical. You have been given mass of the body as 2 kgs. You have been given applied force as 7 Newton. Coefficient of friction as 0.1. Initial velocity 0. Time 10 seconds. So these are the quantities that have been provided. So you will have to first of all find out the acceleration that is produced in the body by the applied force. सब तो पहला acceleration find out कीजिए. Acceleration is force over mass. Force कितना apply किया सी 7 Newton दा. Mass कितना सी 2. So acceleration that a force of 7 Newton will produce is 7 by 2, that is 3.5 meter per second square. फ्रिक्शनल फोर्स किदे इक्वल होंदा है म्यू इंटू नॉर्मल रिएक्शन. नॉर्मल रिएक्शन किदे इक्वल है वेट ऑफ द बॉडी दे. वेट इज इक्वल टू एम इंटू जी. सो फ्रिक्शनल फोर्स इज इक्वल टू म्यू एम इंटू जी. पुट द वैल्यूज. 0.1 is the coefficient of friction, mass is 2 kg, g is 9.8. You get the frictional force as minus 1.96 Newton. Now why this minus sign has been put up here? Because frictional force always opposes motion. फ्रिक्शनल फोर्स हमेशा मोशन ਨੂੰ ਅਪੋਜ਼ ਕਰੇਗਾ. ਸੋ ਜੋ ਤੁਸੀਂ ਫੋਰਸ ਅਪਲਾਈ ਕਰ ਰਹੇ ਹੋ फ्रिक्शनल फोर्स उसके उल्ट होंदा है हमेशा. बिकॉज it is defined as such, it is the opposing force that opposes the relative motion between two bodies. Then find out the acceleration which is produced by the frictional force. How to find it out? Simply divide the frictional force with the mass of the body. The frictional force करके acceleration उल्टी direction च कितनी produce हो गई? minus 1.96 divided by 2. It is minus 0.98 meter per second square. सो टोटल एक्सेलरेशन कितनी हुई बॉडी दी? दोनों ਨੂੰ ऐड कर दो. जो अप्लाइड फोर्स ने एक्सेलरेशन प्रोड्यूस की है प्लस जो फ्रिक्शनल फोर्स ने की है. फ्रिक्शनल फोर्स की एक्सेलरेशन तो नेगेटिव है, अप्लाइड फोर्स की एक्सेलरेशन पॉजिटिव है. सो 3.5 माइनस 0.98 गिव्स यू द नेट एक्सेलरेशन ऑफ द बॉडी, दैट इज 2.52 मीटर पर सेकेंड स्क्वायर. नाउ यू हैव टू फाइंड आउट द डिस्टेंस ट्रैवल्ड, क्योंकि वर्क डन कढ़न दे लई सानू ये पता होना चाहिए है कि कितना फोर्स लग्या बॉडी ते और बॉडी किन्ने डिस्टेंस के थ्रू डिसप्लेस हुई हैगी है. सो फॉर दैट यू विल यूज द फार्मूला एस इक्वल टू यू टी प्लस हाफ ए टी स्केयर. इनीशियल वेलोसिटी तो बॉडी की है ही नहीं सी, क्योंकि बॉडी रेस्ट ते थी. यू कितना सी? 0 सी. So first part of this equation is 0, you get half into a into t square, net acceleration is 2.52, so the body has moved through a distance of 126 meters. Then what is the work done by the applied force? Force into displacement. Applied force is 7 newtons, distance through which it has moved is 126 meters, so work done by applied force is this. What is the work done by frictional force? जिन्ना फ्रिक्शनल फोर्स है उसनों डिस्टेंस नाल मल्टीप्लाई कर दीजिए. व्हाट इज द नेट फोर्स? 5.04 न्यूटन. फाइंड आउट द वर्क डन बाय द नेट फोर्स. इट इज 5.04 into displacement, 635 joule. And then you have to find out the final change in kinetic energy. For that you have to find out the final velocity. So use the equation of motion v equal to u plus at, you get final velocity. Then change in kinetic energy is final kinetic energy minus initial kinetic energy. So put the values. Initial to 0 है value, initial velocity दी, so we have put 0 here, you get 635 joule. So if you see in the C part and the D part, the work done by the net force is equal to the change in kinetic energy. Again this question relates to work energy theorem. Now this question is in the vector form. A body constrained to move along the z axis of a coordinate system is subjected to a constant force of minus iota plus 2 iota plus 3 iota newtons, where iota, 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 they are the unit vectors along x, y and z axis. What is the work done to move a body by a distance of 4 meter along z axis? So you have been given the force, you are given the displacement, work done is force into displacement. Force is minus I plus 2j plus 3k, you have to find out the dot product with 4k. This is a dot product. Now you know I dot k is 0, j dot k is 0, k dot k is 1. So you get 12 joule as the answer. Next question. A pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cube in 15 minutes. If the tank is 40 meter above the ground and efficiency of the pump is 30%, how much electric power is consumed? Again note down what is given to you. You are given the volume of the tank, it is 30 meter cube. Then you are given the time, 15 minutes. As I told you, convert minutes into seconds. 1 minute equal to 60 seconds. 15 into 60 gives you 900 seconds. Next point, you are given the height of the tank, 40 meter. You are given the efficiency of the pump, 30%. You should remember density of water, it is 1000 kilogram per meter cube. Then what is mass of water? Density into volume. So volume is 30, density is 10 to the power 3, you get mass as 30,000 kilograms. Now you have to find out output power. you can obtain output power by the formula work done per unit time. You know, power is time rate of change, time rate of doing work or work done per unit time. So work done कितना होएगा इत्थे जिन्ना सानू मास लिफ्ट करना पै रहा है तो उहदे तो असीं वेट फाइंड आउट कीता उन्ना फोर्स लगाउणा पएगा m into g into h. So work done is mgh divided by t. You are given mass as 30,000 into g into h by t. If you calculate this, this comes out to be 13.067 into 10 to the power 3 watt. So you have calculated the output power. Now you have to calculate the input power. Find out की करना है कितनी power consume की थी. This is the output power of the pump. But for finding out the input power, he has given you the efficiency of the pump. So you should remember the formula that efficiency is given by output power over input power. This is 30%. Now you can calculate input power. So input power is output power divided by efficiency multiplied by 100. So you get the answer as 43.6 kilowatt. So how much input power is required? 43.6 kilowatt. Next question. You are given a body of mass 0.5 kgs that is travelling in a straight line with a velocity a x to the power 3 by 2. A, he has given you a constant 5 to the power half meter per second. What is the work done in moving it from x equal to 0 to x equal to 2 meters. So you are given the velocity as a x to the power 3 by 2. This is the formula that is governing the motion of the body. Body initially is at rest, so initial velocity is 0. Final velocity will be how much? It is given 5 meter per second. So 5 to the you can multiply this, you get 10 under root 2. Then what is the work done? Change in kinetic energy. So half m v square minus u square. Final velocity 10 under root 2 whole square minus 0 square. You get the answer as 50 joules. Next question. A bullet of mass 0.012 kg and horizontal speed 70 meter per second strikes a block of wood of mass 0.4 kg and instantly comes to rest with respect to the block. The block is suspended from the ceiling by means of thin wires. Calculate the height to which the block rises. Also find the amount of heat produced. So as I have told you, first find out what is given to you. You are given the mass of the bullet. So numerical ਨੂੰ ਧਿਆਨ ਨਾਲ ਦੇਖੋ, ਦੇਖ ਕੇ ਪਹਿਲਾਂ ਜੋ ਚੀਜ਼ਾਂ ਉੱਤੇ ਜੋ quantities ਤੁਹਾਨੂੰ supplied ਹਨ, you note them down. Mass of the bullet is 0.012 kg. Initial speed, ਦੂਜੀ ਲਾਈਨ ਦੇ ਵਿੱਚ initial speed ਦਿੱਤੀ ਹੋਈ ਹੈ. Initial speed of the bullet is 70 meter per second. You are given mass of the wooden block 0.4 kg. Initial speed of the wooden block, कोई speed नहीं है initial wooden block दी, it is not in motion, it is in rest, so initial speed is 0. If you read the third line, comes to rest means bullet and the block come to rest. This means final speed of the system, system means bullet plus block, final speed is 0. Applying the law of final speed is v, sorry, applying the law of conservation of momentum, mass of the bullet into initial velocity of the bullet plus mass of the block into initial velocity of the block, then they get embedded, m plus capital M into v. So find out the velocity of the system, it is 2.04 meter per second. So we have applied conservation of momentum here. Now for the system of bullet and the wooden block, mass of the system is 0.412, means when bullet has got embedded inside the block, it is 0.412. Velocity we have calculated is 2.04 meter per second. Height to which the block rises is, let us say, h. Now you apply conservation of energy to this system. Potential energy at highest point equal to kinetic energy at the lowest point. So, m dash g h equal to half m dash v square. M dash stands for mass of the system, total mass, that is mass of the bullet and the wooden block. So, height is equal to half m dash cancel कर गया v square by g, and v you have already calculated is 2.04. So, half into v square upon g, and this gives you the value as 0.2123 meter. So, the height through which the system will move is 0.2123 meter. Then you have to calculate the heat produced. So, heat produced will be how much? Kinetic energy of the bullet minus kinetic energy of the system. Kinetic energy of the bullet is half mu square. Kinetic energy of the system ਦੀ velocity ਅਸੀਂ v find out ਕੀਤੀ ਸੀ 2.04, ਔਰ total mass system ਦਾ that is bullet the mass ਤੇ block ਦੇ mass ਨੂੰ ਜੋ ਜੋੜ ਕੇ ਸਾਡੇ ਕੋਲੇ ਆਇਆ ਸੀ. ਸੋ kinetic energy bullet ਦੀ ਜੋ system ਦੀ kinetic energy minus ਕਰ ਦਿਓ, ਜਿੰਨਾ ਇਹ difference ਹੋਏਗਾ that will be equal to the heat produced in the system, that is 28.54 joules. Now, a 1 kg block situated on a rough incline is connected to a spring of spring constant 100 Newton per second. The block is released from rest with the spring in the unstretched position. Block moves 10 centimeters down the incline. Find coefficient of friction between the block and the incline. A bit difficult, but you do not have to worry about this question. This is the diagram. You see, this is a spring constant and this is force per unit length 100 Newton per meter. 1 kg block is here. So, mass of the block is 1 kg, spring constant is given, displacement is given. Now, you resolve the components. You see, resolve weight into its component. This is the weight mg, and mg cos 37 will balance the normal reaction. Mg sin 37 will move the block downwards. So, when equilibrium is there, then normal reaction is equal to mg cos 37. You see, R is equal to mg cos 37. Frictional force F, F किदे equal होएगा? Mu R दे, R is mg cos 37. So, mu mg cos 37. So, here this is frictional force mu R. ये किदू balance कर रहे mg sin 37 नु. So, frictional force balance करेगा mg sin 37 नु, और net force नीचे नु कितना होएगा mg sin 37 minus frictional force, mg sin 37 minus mu mg cos 37. You get mg sin 37 minus mu cos 37. So, when the equilibrium is there, work done by the block is equal to the potential energy of the system. तो work done कितना आया थी mg sin 37 minus mu cos 37 into x. This was the force that we had calculated. Distance now multiply करता equal to half k x square. So, from here you can calculate mu. Mu comes out to be 0.115. So, this is how we can solve the numericals pertaining to work, power, energy and friction. This is the method which is used to calculate the numericals. So, numerical करने तो पहला again I advise you कि first of all you read the numerical once, twice, thrice, note down the quantities that are given to you, note down what you have to find out, put the formula, you remember what formula is to be used. थोड़ा ध्यान दोगे तो तुहानू फार्मूला ध्यान आ जाएगा कि किहड़ा फार्मूला तुसीं यूज़ करना है. उस फार्मूले दे विच गिवन क्वांटिटीज़ नू फिट कर दीजिए and you will get the result. Thank you.